Assalamualaikum warahmatullahi wabarakatuh. And good morning to everybody. Okay, today I would like to share with you my lecture notes, okay, regarding the torsion for EBB 344 mechanical metallurgy. Okay, for your information, the torsion topic is the last topic for me for EBB 344. So please pay attention for this topic because this topic normally in final exam or the test question, most of the question from the torsion topic normally is the calculation based question. So please pay attention what I try to convey message to you. So and then please take some very important notes when I ask you to do so. Okay. All right. This one just a brief introduction about the torsion. Okay, I think you can read the information that I give to you on the slide, but I want to attract your attention regarding what is the torsion means. Okay, in simple word, the torsion means something like the loading by couple that produce twisting of the member about its axis. Okay, so imagine you have one or a metal rod, and then you rotate the metal rod by applying the load, okay, in opposite direction. Okay, when this metal rod twisted, so this why that one we can call as a torsion condition. Okay, three fundamental torsion deformation. Okay, number one is that uh, the axis remains straight and remain in inextensible. Okay, meaning that the axis, let's say for example in the x-axis, okay, and then they cannot be extend. Okay, the fixed, let's say you have the fixed length, and then you apply the load at the edge of the metal rod in opposite direction. Okay, and then number two is that every cross section remains plane and remains perpendicular to the axis. Okay, so meaning that you have this metal rod, okay, and then this cross section is perpendicular to the axis that you have rotate. Okay, number three is that the radial lines remain straight and radial as the cross section rotates about the axis. Okay, meaning that in this case, the radius of the metal rod still remain. Okay, so the rest you can read through this slide. Okay, uh, I think I explained to you in the previous slide, but now I want to show to you uh, one video. Okay, this video you can watch it when you download my slide. Okay, you can watch it online when you download my slide, and then you can open this file. Okay, I try to find the example for metal rod, but I think this one I just take example how the torsion mode has been conducted. Okay, has been present when you apply the load at the clamp at the edge of the material or the product. Okay, you need to watch this video. Okay, as you can see here now, the load has been applied, uh, and then the edge of the sample has been clamped. Okay, and then the the rotation the rotation load has been applied. As you can see here now, now the sample rod is twisted. Okay, and then now start to fail. Okay, you can see they have some rotation here. Okay, you can see this the another surface at the side of the sample. Okay, as you can see the sample is rotate, and then just wait until the sample is failed. But in this case, I just use example the wood materials. Okay, the wood product. So it means that they need to cut into the standard American standard testing method, STM. Okay, you can see this one, the sample dimension or sample preparation. As you can see here now, the sample actually is twisted. Okay, you can see the sample is severely twisted and just wait to fail. Okay, as you can see now, the surface of the sample start to chip off, and then just wait for the sample to fail. Okay, I just forward a little bit the video so you can see now uh, the, the product or the sample start to fail. Okay, it become peel off and then broke together. Okay, and then okay, okay, this one the setup for torsion test. Okay, so later when you uh I think when you do your when you do for your final year project letter that related to composite, to metal, uh, normally you will do distortion test, but it depends on the application. Okay, the rest of the video you can watch later on my slide. Okay, and now I want to attract your attention. Okay, attract your attention. Okay, uh, normally when the engineer car design the car, okay, in this particular case, okay, I want to uh, attract your attention regarding uh, one of the common failure in car, okay, that related to the torsion condition. Okay, as you know, I think the most related part that use the torsion fundamental is inside the drive shaft of the car. Okay, this one I want to uh, give some example about the Nissan X10A draft shaft failure. Okay, as you can see on the at the bottom. Okay, this one the drive shaft of for the Nissan X10A. So you can see uh, these these two different condition, okay, of the fracture mode after this car experience the torsion failure. Okay, what is the torsion means? Okay, normally what is the drive shaft for the car? Okay, uh, I cannot show you the design now. Okay, I think you should Google it. How the where we install the drive shaft for the car. Normally at the front and the rear back of the tire. Okay, when you have something like connection between the front tire and the back tire, okay, they have something like shaft that can run the tire. Okay, so uh, that's why if doesn't care, let's say you drive uh, you know uh, Myvi, Nissan type, Toyota Vios or whatever, the most common failure for the car is shaft. Okay, that's why over the years, okay, when you go for the service, the technician or the supplier customer services always recommend you, let's say after you drive about 300,000 kilometer, you should check or you should replace your drive shaft. But it depends how you use your car. Okay, let's say are you frequent long travelers, are you only for the short distance travelers and others. Okay, all right, so now as I mentioned, uh, when the drive shaft face the torsion failure, okay, normally for ductile metal, I repeat again, normally for ductile metal, okay, when the torsion failure has been detected, okay, so when the drive shaft is broke into two, okay, you can see the 45-degree angle of the fracture surface. Meanwhile, uh, okay, this one the fatigue fracture of the 300 ultra high strength steel race car. Okay, so another condition, okay, is that when the metal rod or metal rod sample, okay, experience the torsion condition, okay, when it exceed the torsion maximum load, okay, the sample will break into two. Okay, this one another example how the fracture surface looks like after this sample experience the torsion maximum. I mean, this metal rod experience uh, excessive torsion load, okay, on the metal rod. Okay, uh, I don't want to explain more on this because this one only just an example. Okay, I want to bring your attention. Okay, normally where in our daily life we apply the torsion condition. Okay, this one I give. I think some of you have experience. You change your own tire. Uh, you change by your own tire by your own. Okay, meaning that let's say tire you punctured. Okay, and then you need to put aside the road, and then you need to replace the tire by your own by using the emergency kit given by your car manufacturer. Okay, so the most important tools when you change the tire, something like you have the jack. Jacks meaning that you need to support your car body, and then you need to jack. Okay, and then you need to, before you remove the tire, you should apply this, how I say, the name of this one, the lug wrench. Okay, the lug wrench meaning that something like the T shape of the wrench, and then you need to put on the tire, and then you need to rotate the wrench. So means that during this you need to apply the load as well, because when you apply this one, okay, when you apply this lug wrench, the lug wrench made from the steel, from the metal. Okay, and then when you rotate it, okay, there of course they will apply the torsion inside the lug wrench as well, towards the nuts or bolt that installed together with the tire. Okay, so this one I just want to give you example how the torsion mode has been applied in our daily life. Okay, uh, I think I don't want to explain more on this because I think this one you have learned when you still in matriculation or STPM. Okay, regarding the right hand rule of the torsion. Okay, so this one I think the basic formula for the torsion. Okay, as I remind you at the beginning of my lecture. Okay, normally for torsion topic, okay, the questions is rarely asked as a theory. Okay, normally question related to torsion, uh, we design normally as a calculation based question, meaning that when you can see when the calculation questions come up from the test or for the final exam, normally that question related most on the torsion topic. Okay, so this one I think you know already the formula for the torsion equal to force times load. Okay, so not sorry, force time load. uh, torsion equal to force time the distance of or the length of the metal rod. Okay, so that's why in particular for torsion application, okay, the load and the distance of the metal will determine the torsion mode. So that's why as you can see, I'll give you a simple example again. Okay, let's say in this lug range, okay, normally you need to have appropriate distance of the lug range in order for you to rotate easily the screw of the tire. Okay, let's say what happen if you use the short uh, lug range. It's difficult to remove the nut or screw. Meanwhile, uh, if you have the quite quite long of the lug wrench, for you I think it's easy for you to apply the load with minimal load that you need to use it. Okay, so the distance is play important role in order to manipulate the load that has been applied on the lug wrench. Okay, So in this case, I think, of course, when the metal rod is twisted, okay, when we say the twisted of in your mind, you must have something like the rotation involve angle. Okay, bear in mind, as I mentioned earlier, for torsion normally we have the right hand rule. Okay, I think bila you belajar, I think in the uh, strength of materials, okay, strength of materials, you will apply the load, right? So normally this right hand rule is really important. Okay, the rule is that uh, the mother finger, okay, normally refers to the top direction. Okay, the another four fingers, when you close your fingers like this, is referred to the uh, apply force on the metal rod, or on the specimens. Okay, and then when you rotate, okay, this one, they will produce the angle. Okay, remember, the angle involved in the torsion always need to convert in radian. Okay, if you use calculator, it's easy to convert radian to angle and then angle to radian. But in torsion question, the most popular way to ask is that we give to you uh, the angle in degree, and then you need to convert it into the radian mode, radian units calculation. And then you need to use this kind of calculation in order to, let's say, to determine the torque, or to determine the apply force. Okay, this one, the right hand rule formula. Okay, normally torque we know as a T. Okay, I'm not sure what we call this one, but normally it's a T equal to R F sin theta. Okay, what is the R means? Okay, R means that the radius. Okay, radius of the of the uh, metal rod, or the shaft, or whatever. Okay, so I think that's the first part of my lecture video regarding the torsion mode. Okay, in mechanical metallurgy application. So in my next video, I will brief you more, how I say, to mathematical way. Okay, how to use the torsion, how to compute, or how to derive the equation. Okay, so because, as I say before, normally for torsion is very rare to see the fundamental has been asked. Okay, normally the question related to the mathematical questions. Okay, please stay tuned with me. So see me in the next video. Thank you.